Much of the Midwest used to be prairie, and right now, of all the different types of prairie ecosystems, only about 1% remains, and only about 0.1% of the tallgrass prairie ecosystem that I study still remains. Tallgrass prairie plant species are long-lived. They're called perennial plants, and so that means that they're able to grow extensive root systems. Some of these species grow roots that go 20, 30 feet into the ground. That's a ton of biomass, and they put a lot of carbon that they take out of the air into their root system. And then also, because those root systems are so extensive, they're really important for things like flood mitigation. We've ripped out a lot of the biomass, the plants and different ecosystems around our rivers and places like that. Those are often buffers and protect our communities against flooding. And without those, we end up having major flood issues like we've been seeing over the past few years. And so in prairie restorations, we have a lot of species that you'll find in remnant prairies, and those are prairies that were never plowed for agriculture, that were not able to get to show up. We have hypotheses for why this might be. Maybe they just take a really long time to germinate, or they don't like competition with other plant species. But it seems like there might be something more going on, and I'm hypothesizing that soil microbes that benefit these plant species may be lacking in these restoration sites. And if I add the microbes that these plant species need, then I can get these plants to grow much bigger and much faster than if those soil microbes were absent. A good analogy for this is thinking about your gut microbiome. People take probiotics a lot to try to improve their gut health. And so if you think about adding soil microbes to an ecological restoration, that's just like us after taking a bunch of antibiotics and having wiped out the microbiome in our stomach, needing to replenish the microbes with beneficial microbes. My plots are structured in a way that not only takes into account the soil microbial community, but it also takes into account how closely related plant species are to each other. I've actually found that even after just a few months of growth, the hard to establish plants grow much, much bigger whenever they're in those plant communities that are more distantly related to them. So far, I don't have a soil effect, but I took those data back only like 5 months after I'd started the experiment, so it's not surprising. But what that is saying so far is that these plants really compete a lot with the different plant species that are more closely related to them. So maybe they share some similar ecological requirements. They take up nutrients in a similar way, but whenever they're in communities that are more distantly related, they're somehow released more from that competition. So this is really useful for people who are doing ecological restoration. If they want to get, say, the prairie milkweed to be able to establish, and they know it's not going to grow as well whenever it's growing right next to plant species it's more closely related to, then maybe in that particular area, they need to make sure the other plants that they put around it are more distantly related. So that's a big goal of my research, to be useful to people who are actually going out and doing applied research. That's my whole goal of my graduate work.